Hello everyone, it's Mr. Wolfe here, and in this video I'm going to be explaining how our body maintains homeostasis of blood glucose levels using the hormone insulin. All right, now this is our bloodstream right here, and it's a simplified version of a bloodstream, but it does the job because blood is constantly circulating around the body. And let's just say for our purposes that homeostasis is going to be 4 glucose molecules in the bloodstream. Now what's going to happen is throughout the day you're going to eat a meal that's going to be, let's say, made out of carbohydrates and is made up of a bunch of glucose molecules, right? Now this glucose you want into your bloodstream, so it could go to your cells, but it's too big to just get into your bloodstream. So your small intestines help break down that glucose into individual monomers, and then that glucose enters the bloodstream, all right? So now all of a sudden, all right, I've got a lot of glucose in the bloodstream. That's good because that'll allow it to travel to all the different organs in our body, but it's not good because having too much blood glucose or having too much glucose in your bloodstream could cause damage to your liver, heart, eyes, feet, definitely kidneys, right? And so what's gonna happen is once that glucose gets into your bloodstream, your pancreas is an organ that senses that. It's like, oh my gosh, we have too much blood glucose, we need to do something about it. So what they're going to do is they're going to secrete this hormone called insulin into the bloodstream, all right? Now, the insulin, what it does is it doesn't do really anything to the glucose. It travels through the bloodstream just like the glucose is doing, and it's going to go to your liver, all right? It's going to go to your muscles. It's going to go to your fat cells even, all right? And what insulin does is it messages these cells. It says, hey, liver, we need to take in glucose. Muscles, we need to take in glucose. Fat, we need to take in glucose. And that's exactly what's going to happen. So some of this glucose is going to get taken into the liver. Some of this glucose is going to get taken into the muscles. Some of this glucose is going to get taken into fat. I'm going to bring some over here to go into the liver, some over here to go into the muscles, all right? Now, a lot of times it'll just kind of go to your liver and muscles, and you'll use the glucose in your muscles for energy, and the liver is storage for later. But let's just say that you have a lot of glucose and it needs to store it somewhere else. That's when some of the glucose will go to your fat cells as well. All right, only if you have extra glucose that you can't go to your liver and your muscles. All right? Now, what ends up happening in your liver and muscles is sometimes your muscles will use this right away. All right, but if they want to store it for just a short term, they're going to build these glucose molecules into glycogen. The same thing is going to happen in the liver. Those glucose molecules are going to join together to form glycogen, all right? So look at what insulin did. It by being released from the pancreas, it told these other organs to bring in the glucose into their cells. And look at our blood glucose levels now, guys, right? They have gone back to homeostasis. We're back to the original 4 glucose molecules we had before. So the response by the pancreas to secrete insulin, that is the negative feedback in this scenario. All right, thanks for watching.